In this video, I'd like to continue talking about the period of sinusoidal functions from their equations. And specifically, I'd like to look at several different example problems where we are given the equation for our sinusoidal function and we need to determine its period. Now, in a previous video, we talked about the general equation for these sinusoidal functions. It could be either sine or cosine. But the main idea is that your function y, or g of x or f of x, would be equal to a multiplied by the sine or the cosine of b times x plus c, and then we will add d on the outside. And each of these letters, a, b, c, and d, will affect this sinusoidal function in different ways. For instance, a will affect its amplitude, B will affect the period. C will affect whether or not we are shifting left or right the entire function. And D will shift the entire function up or down. This will affect our midline. Now, since we know that B, this coefficient on the independent variable x, will affect the period, that's what we should concern ourselves with. In this case, we need to look at this coefficient being equal to 7. And again, this general equation could be true for either sine or cosine. It doesn't actually matter. And remember that the formula for our period based off of this general equation is that the period is equal to 2 pi divided by the absolute value of b. And we know that the parent function for sine and cosine, the period of that is 2 pi. And this coefficient on xb essentially just scales the function horizontally. So by multiplying by 7, we are actually cutting the period of the parent function into 7 parts. Or we are essentially looking at 1/7 of the period of our parent function. And likewise, if this was a fraction, then the period would actually become bigger compared to our parent function. And we look at the absolute value of this coefficient here. Since if it was negative, the negative essentially just causes a reflection horizontally. So if this was negative, that wouldn't actually affect the period, just the magnitude or the size of this number actually contributes to the period. So for us, we can call this P for period. We have 2 pi over the absolute value of 7, which is just 7. So the period of this function is simply 2 pi over 7. And this is something we can check with a graphing calculator by plotting this on a calculator, and then we would essentially get some sinusoidal function. And just looking at the distance between, let's say, 2 consecutive maximum values, 2 consecutive minimum values, or really just any full oscillation, one unique oscillation of this curve. So this right here would be one period as well. So there are many different ways to check it once you graph this on a computer graphing program.